A Carnegie Institution for Science audio press release for November 10, 2014. Mapping reveals targets for preserving tropical carbon stocks. A new high-resolution mapping strategy has revealed billions of tons of carbon in Peruvian forest that can be preserved as part of an effort to sequester carbon stocks in the fight against climate change. Tropical forests convert more carbon from the atmosphere into biomass than any other terrestrial ecosystem on Earth. However, when land is used for agriculture, as a wood source, or for mining, carbon is often released into the atmosphere, where it contributes to climate change. Tropical deforestation and forest degradation account for about 10% of the world's carbon emissions annually. There remain major challenges to conserving the carbon that's stored in these tropical landscapes on a national and international scale. A team led by Carnegie's Asner developed a new high-resolution approach for prioritizing carbon conservation efforts throughout tropical countries. Their findings were published the week of November 10th in the Proceedings of the National Academy of Sciences. The team of authors emphasized that the low cost of conducting their project means that the same approach can be rapidly implemented in any country, thereby supporting both national and international commitments to reduce and offset carbon emissions. Many of the geographic details about the carbon that's stored in tropical forest ecosystems remain unknown. In order for people involved in conservation efforts to select new areas in which carbon stocks can be best protected and enhanced, detailed information on which areas would make the best targets for protection are necessary. This means understanding each landscape's climate, topography, geology, and hydrology. Using advanced three-dimensional forest mapping data provided by the Carnegie Airborne Observatory, or CAO, integrated with satellite imaging data, the team was able to create a map of carbon density throughout the 128 million hectare, or 320 million acre, country of Peru, at a resolution of 1 hectare, or 2.5 acres. Asner explains that researchers found that nearly 1 billion metric tons of above-ground carbon stocks in Peru are at imminent risk for emission into the atmosphere due to land uses such as fossil fuel oil exploration, cattle ranching, oil palm plantations, and gold mining. The good news is that the high-resolution mapping was able to identify 3 strategies for offsetting these upcoming emissions. The team determined that there are opportunities to establish additional protected areas in some lowland Amazonian regions of Peru. There they found very high carbon densities, as well as in the so-called submontane region. This region exists between the lowland Amazonian and Andean highland regions. Together, the lowland Amazonian and submontane forest offer about 30 million hectares for potential new protected forest areas, which may be able to store close to 3 billion metric tons of carbon. Manuel Pulgar Vidal, Peru's Minister of Environment, says that research is necessary to determine the exact state of our forest. For that, the Carnegie Institution, with the support of the Peruvian Environment Ministry, has developed the first high-resolution map of Peru's carbon stocks. This new map provides the evidence needed to start negotiating in the carbon market at a bigger scale. The Peruvian government is also studying carbon stocks in the soil, is doing a forest inventory, and has a forest investment program. These initiatives will better prepare the country to face changes in land use. The team also asserted that there are further opportunities for offsetting future emissions by improving enforcement in areas that are already designated for protection of carbon stocks. According to their research, the majority of already protected carbon stocks exist only in 10 parks and reserves, and just 4 of these are fully enforced. Asner said that transitioning partially protected preserves to fully protected ones would help to counterbalance a great deal of the carbon that's expected to be lost due to land use in the near future. Other suggested measures include reducing forest disturbances that occur in the wake of logging and oil operations. Reduced impact logging and restricting road access to areas where oil is being extracted could make a major difference to the net carbon emissions from the country, the team said. This image is from the Peru-wide high-resolution carbon map showing the effects of deforestation, ranging from the blue, where there's no more carbon remaining, into a region of ultra-high carbon stocks in the surrounding forest in red. You can see massive losses in the bustling city of Pucallpa on the right side, and the thousands of small farmers spreading into the forest to the west of Pucallpa. This image is courtesy Craig Asner. With the independence for nimble pursuit, Carnegie scientists tackle some of the most profound challenges in modern science, fundamentally changing what's possible for us, our planet, and our universe.